Welcome to the world of Insignis. God, I think it's been probably over 4 years since I last uploaded a video. Really, the whole purpose of this channel was to bring you guys along with me as I set out to build a game using only browser-based technology. While I've used, Unity and Unreal in the past, I've always had a passion for building things that can run in the browser and trying to push the limits of what's possible. Although I'm building a 2D game, so it's not really anything too groundbreaking. But this game is built using Phaser 3, which I highly recommend if you're building, especially a 2D based game that runs in the browser, that you take a look. They're doing some really great things over there, and happy to share a link to the GitHub page for Phaser, and also happy to answer any questions that you might have, as I've done a pretty decent amount with that game engine. Behind the scenes, I'm using what's called an entity component system to build out the game in a data-driven way. And I'm not going to go into, at least not in this video, what an entity component system is, but just know it's sort of a replacement for the typical object-oriented style of game development. But really what I wanted to do in this video was show you guys the progress I've made towards building a trading system. And I've really tried to model this after the way the trading system works in Divinity Original Sin 2. So hopefully you guys can see the resemblance there. And I'm going to talk through what some of the features are, some of the challenges that I've run into and how I've solved those problems. So yeah, let's go ahead and take a look. So let's walk on over here to our buddy Gore, who is the trader in this little starting area here. So we'll go ahead and click trade. So first thing you might notice is, hey, who let the programmer design the UI for this? Jokes aside, I did try to make this look somewhat like Divinity Original Sin 2. So there's really 4 what I call inventory grids that you'll see here. So on the left side, we've got what I call the player inventory grid. That should be pretty self-explanatory. These are the items that the player has for trade, that they can put up for trade. On the far right side, we've got the items that the shopkeeper has for sale. It'll also have the items that you sold to the shopkeeper that you can buy back. The 2 middle grids here are sort of what I think make Divinity Original Sin unique. And not that other games haven't done this, it's just the one that's probably freshest in my mind. But this middle left grid here is what I call the in play items. So these are the items that the player has put up for trade, that are in play for the trade. The middle right are the items that the shopkeeper is putting up for trade or that you're requesting from the shopkeeper. And so the concept of the trade is you're trying to balance the value of the 2 middle columns by either matching item value or, associating gold to sort of fill those gaps. So let's take a look at how this actually works. So let's say, for example, I want to sell this dagger to our NPC here. So I'm going to add it to the in play window. The shop window knows how to calculate the items. So it knows this dagger is worth 6 gold. So next thing I'll do is say, okay, well, Mr. Gore over here has plenty of gold to be able to buy this dagger from me. So one of the unique things about Divinity Original Sin is the balance button. So by clicking this, I can automatically pull in the amount of gold that I need to make the trade equal on both sides. So you can see I've deducted the 6 gold from the NPC's inventory and moved it into the shop window. So right away, I ran into some challenges with this because I'm treating gold as an actual item in the game. It's not just a number. A lot of games use gold as a currency that exists just as a number, probably attached to the player object somehow. But gold items are actually items in my game. So that means in order to break out a piece of, a sliver of gold from the stack, I've got to split the stack. So behind the scenes, what I actually do is I say, okay, I check all of these slots for gold. I get a list of all the gold items that the NPC has. And then I sort them by lowest to highest. And so it will actually go and try and find the right combination of stacks that it needs to use to essentially match the trade. So in this case, there was only a single stack of gold, so it just split out 6 from there. But where you start seeing some of the more complex behavior is when you have multiple stacks of gold, which I can show you in a bit. But let's just say, okay, this is an easy trade. Let's go ahead and accept it. And you can see that we moved the dagger over to the NPC's inventory and we got the 6 gold. So we started at 27. We have 33 now. If Mr. Gore had some items that we wanted to buy, we'd have his 6 gold now that we could use to buy items back. So base case works. That was probably one of the more easier examples to show you guys. So we can do a little bit of live testing here. So let's build a more complex example. So what happens if I say, okay, I want to sell this for 4 gold. I balance the trade for 4 gold. And then I say, okay, well, actually, I want to sell 2 items and I want to balance this trade again. Now you've got added complexity because I have to know how much gold, not only how much gold is in the shop window in place, so this right column here, but I need to know which slot it's in, because I think the way that I would expect this to work is I'm not going to just take 2 gold and add it to another slot. I want to take that 2 gold and add it to the existing stack. So that stack would become 6 gold. So hopefully this works. Let's see. I haven't tested this one yet. Okay, beautiful. So I took 2 gold away from my inventory, moved it to the shop and play value, and now the trade is equal again. So we can do it the other way too. So what happens if let's say I remove this 6 gold, right? So it goes back into inventory. Let's take this back away. So let's say now, okay, I've got a value of 4 gold in my inventory for sale. I need to balance the trade and grab 4 gold. So what I would expect to happen as a player of the game, at least personally, I would expect it to take the 4 gold out of the stack with 6 and not the stack of, 820. So let's see if this actually works. And it kind of worked. So we did grab a stack of 4 and the value of the gold updated, but it looks like this stack did not update. So there might be our first bug. I'm assuming maybe it didn't receive the quantity updated event and stayed at 6. Let's see actually if I can, like what happens now if I move this over to and play. Okay, so it did update. So this is probably just a UI bug. It seems as though the actual state of the inventory was correct and just didn't update the UI correctly. So now if I accept this trade, well, actually that wouldn't work because I've only got 4 gold over here. So I need to balance the trade again. So now I would expect to take 2 gold from player's inventory and move it over to the in play, which it does. So 6 gold on both sides. You can see all the values updated. Now if I trade here, I'm giving 2 gold, I'm receiving 6. I would expect to have 37 gold at the end of this, and Gore should have 822 gold and then also this extra item. So 822, 37, and it received the item. So beautiful. Caught a little bug there, probably pretty easy to fix, but that's probably one of the more complicated examples where you're doing multiple layers of balancing and you've got to split the stacks and keep track of the stacks and make sure that you're not, duplicating gold, because I ran into a ton of duplication bugs along the way. But for the most part, it seems like things are working pretty well. So before we get into how we actually built the trading system, which I'm sure is why everybody's here to begin with, the only other real feature that we've got is drag and drop. So we have the ability to move items around, drop them in the inventory grids, and we can accept trades and things just work. Yeah, so drag and drop, that's a fun one to implement. So let's go ahead and jump into how this actually works. And I have open sourced the code. So I did pull the code out of my actual game and I put it in a different repo. And I'd love to share that with you guys. But before I do that, I want to talk through some of the design decisions and how this functionality could theoretically be expanded to your game, or whatever it is that you're working on. So let's take a look at a diagram that I've put together that hopefully will allow me to communicate to you guys how the trading system actually works. So in my mind, there's really three components to this trading system. There is the gameplay rules state management aspect, which is like, how do we track the state of the items and where they're at within the player's inventory, as well as how we track where they're at within the shop window. There's the presentation layer, which is the UI, right? Which is, how do I render the state of my player's inventory, and how do I render the state of both the shopkeeper's inventory and the trade window, and how do I render all of the items and all of the things in the game. And then there's this middle piece, which arguably has gotten a little complicated, but it is the thing that knows about both the UI and the kind of the core logic of the game. And its job is to listen to events from both sides and sort of route those requests to the appropriate functionality. So just to give you kind of a quick flow here. So presentation layer would be, these are the actions the user is taking. So as you move items around and click buttons, it's going to send events up to the mediator here. Mediator knows how to interpret those events. So think of things like item dropped, item moved, balance trade. It's going to know how to take those and route that over into our shop system, which then goes and does all of the updates to the internal state of the game. Once it's done doing all of its updates, it now needs to let the UI know that it needs to re-render its state, needs to update its state. So let's get this thing out of here. How do we move this? I don't actually know. I haven't used this tool too much. There we go. So then we will send more events back. The mediator shop window manager will pick that up, and it will then route that request to the appropriate thing in the actual presentation layer, which will kind of manifest itself with an updated UI. So to give more of a concrete example of what might happen is, let's take a look at, give me 1 sec. I'm going to pull open the actual code and give you an example of how the flow works. Well, I guess before we get into the actual code, maybe we should dive a little bit deeper on some of the things in the presentation layer to explain a little bit closer. So let's kind of zoom in to just this piece here. So might be a little bit confusing at first. Essentially what you're seeing is 4 inventory grid managers. Okay, what is an inventory grid manager? Well, it manages a collection of item slots that I've tried to denote here with inventory grid slot with the kind of open array to indicate that it's an array of slots. So its job is to know about the slots that it manages and knows how to find the correct slot based off of the index that you provide. So the reason that there's 4 is because if you think back to our shop window has 4 separate inventory grids. So each one of those has its own inventory grid manager. If you are building just a normal inventory, grid, you would only have one inventory grid manager. So the only reason that there's 4 is because my shop window has 4 inventory grids. So an inventory grid slot is basically just a, trying to think of a good way to put it, but it's just a bucket of functionality that is defined by the behaviors that you give it. And the behaviors that you give it are defined by kind of these 4 different pieces here. So the item manager is responsible for handling all of the item interactions, not the item interactions, it's responsible for handling the item removal and the item adding aspect of the inventory grid slot. So anytime you add an item, it will go and call the item manager, and the item manager will then handle, creating the item. It will check to see if that item has a quantity. If the item has a quantity, it will create a quantity object, which is obviously the little number that you see at the bottom. Likewise, if you remove an item, you will call the item manager and it will remove the item from the slot, and it'll clean up after itself. The drag manager is responsible for handling obviously the click and drag functionality that you saw just a little bit ago. The pointer event manager is responsible for handling click events. So if you wanted to build some custom click logic for your inventory grid slot, so maybe, in your inventory, if you double click, it'll automatically equip an item. But if you double click an item, in the trade window, maybe it does something different. If you double click an item like in a skill bar, maybe it won't do anything. So you can define different behaviors based off of the way the managers are built, as long as they adhere to the same interface, which is sort of the point of building the inventory grid slot using a more composition style versus object oriented. And the idle info panel manager is the little pop-up that shows when you hover over an item. So it's the item info. It shows the details of the item. Depending on your game, that could be a wide variety of different things. So that can all be customized based off of your requirements. So one of the nice things about doing it this way is you can compose different behaviors for your inventory grid slot based off of the context that the inventory grid slot is in. So you're not tied down to just one set of behaviors. You can pivot off of the context. Context being, is this in my inventory? Is this in a trading window? Is this in an action bar? Is this a container, a chest? Did I open a chest and now I need to click items out of there, and that needs to do something differently? So it can be easily customized based off of the needs of your game. But let's take a look maybe at actually some of the code and walk through an example of what happens when I actually click an item in the trade window, and where does it go, and how does it know how to re-render itself? And we'll walk through the full life cycle of one of those events. So starting point for the inventory grid slot here, we're going to walk through what happens when the user shift clicks an item in my shop window. That's the behavior that I defined to move the item into kind of a defined context. So in my case, when you shift click the item, we expect it to move into the in-play grid, which is going to be an item that's available for trade. So up on the screen, we've got, let's get a little more real estate here. We've got our inventory grid slot class. So if you remember the diagram, there's 4 managers that are responsible for defining the behavior of the inventory grid. So those are passed in via this register managers class. And each of these accept a sort of like base interface that define the methods that need to be on these managers in order for the inventory grid slot to actually function. So if you don't call this class with your set of managers and you try to call one of the methods on the actual inventory grid slot, you're going to throw an exception because something might be null, and we don't want to do that, obviously. So let's just catch it early, because we don't want to find out way down the line that we forgot to define something, and then this just makes it nice. So if you remember back to our diagram, the thing that handles the click events is the pointer event manager. So let's take a look at what this does in our case. The pointer event manager is the interface that needs to be implemented in order to handle click events on an inventory grid slot. So in our game, we've implemented an inventory grid slot pointer event manager, which is a mouthful. This could easily be something like shop window pointer event manager, or action bar pointer event manager, skill bar pointer event manager. You name it, you can define it how you want. I only have one for this one example, so I've defined it just using the name of the actual inventory grid slot. So this class is coupled to Phaser in the sense that it knows how to set interactivity to a Phaser game object. So the slot sprite itself is a game object in Phaser, so the little rectangles for the atom slots. We call a set interactive, and then we give it 4 different pointer events. So pointer over, pointer out, pointer down, pointer up. Pretty standard. It's even some similar functionality that you would have in something like Unity. In our case, pointer down, I believe, pointer up is where the slot click functionality occurs. So when a user shift clicks the item, I guess just any click, we check first, does the atom slot actually have an item? If it doesn't have an item, in this case, we don't really care to bubble anything up to the state management. So we return early. If shift is down, or if shift was just down, and this is like a Phaser nuance thing, sometimes based off of when the action occurred, one of these will be true, but not both of them, at least from what I've seen. We call this item slot handle slot click. So we actually bubble the event. It's not an event yet, but we bubble it back up to the item slot itself. So we don't necessarily need this because we already checked that the item has, or the atom slot has an item, but this is checking again, hey, in the case of you clicked on a slot that doesn't have an item, we don't care in this particular instance. So if it does have an item, we're going to emit an event called inventory grid slot event dot item clicked. And it's going to bubble up some information that is needed to actually move the item where we want it to move. So if you think back to the diagram again, the thing that knows about these events is the shop window manager, because it knows about both the presentation layer, which is where we're currently at, and it knows about the state management system. So let's open the shop window manager here. And this class is kind of beefy, and I've kind of thought, should I look to split it up, clean it up a little bit, but it does all the things that I need it to do. So I don't want to over engineer it too much. So you might recognize the 4 different inventory grids here: player inventory, player and play, shop inventory, shop and play. So when this is created, we loop through each of the events and we subscribe to a couple of different events. In the case of you shift click an item, the thing that we're subscribing to is item clicked. So this event is going to pick up, is going to fire whenever a user shift clicks the item. And it's going to call move item in play, and it's going to take the actual item itself to move. So let's take a look at where we end up at this point. So we're in our shop utilities. It's not a class, it's just a collection of functions. So shop/state/shop utilities, this is the logic that's actually going to update the internal state of the shop. So first thing we do, we grab the shop window state from the player entity. So the shop window, you can think of it as just, it's an object that has 4 different buckets of slots. And a slot is comprised of an item, which is the ID of the item, and the slot index, which is obviously where the slot is within the array. So first we grab an instance of the shop window from the player. We try to find in the shop window inventory, which in this case is the player inventory, we try to find the slot based off of the ID of the item. If that slot doesn't exist, it means you try to move the item to an invalid slot. I don't throw an error here because it's not really a big deal if this happens. We just return early and kind of ignore the player's action. I don't think that it actually ever makes it to this point if this thing actually happens, but just in case, a little bit of defensive programming. So assuming we get this far, what we want to do, we want to remove the item from the slot that it's currently in. So we say, okay, let's remove the item by calling this function on the item slot itself. And so this slot is not the inventory grid slot that's in the presentation layer. This slot is part of the internal state of the player's of the player entity. And so it just has, we can take a quick look, but it just has some helper methods on here. So has item, add item, and remove item. So it's just a way to kind of manage the internal state of the actual inventory. So we get that item. Now we've got to find the target slot that we want to add the item to. So the way that we do that is if target slot index is provided, then we want to use target slot index. So there are some cases, in the case of where you drag and drop an item, you're kind of telling the system, I want to put this item in a very specific slot, in a target slot. If you just shift click an item, then all we want to do is find the first available slot that doesn't have an item. So in the current example that we're working through, we are going to fall into, it's kind of last else statement here, where we're going to grab a slot from the in-play inventory grid that does not have an item. So that's going to give us our target slot. So then we want to add this item to the new slot. So we say, now that I'm looking at this, actually, I kind of have a little bit of duplication here. So realistically, I could just do this, target slot dot add item, removed item. And that would be just fine. And we don't actually need to index into the inventory grid again. Once that's complete, the state has now successfully been updated. So quick recap of what we did. When you click the item, we fired an event. The shop window manager picked up the event. It called the function that it knows it needs to call, which is move the item in play. So it removes the item from the player's inventory and moves it into the shop window by removing the item from the item slot and then adding it to the new item slot. Now we call, the item added event. So the shop window manager is listening for this event particularly. So we've got to give it a couple of different things. So we need to tell it what is the target slot index? Where did the item move to? In this case, I've got an enum that lets me define that, which is called player in play. So the player moved an item from their inventory to the in play grid. The current slot in context is where was the item, or where does the item currently exist in the UI, because it needs to find it and do the same functionality in the UI that it did sort of in the backend, internal state of the system. Likewise, I give it the slot indexes for both the target and the current and in the actual item ID itself. So what we need to do now is go back to our shop window manager and find where we've subscribed to this event. So we've subscribed to the shop system, not quantity updated, but item added. So this is where we land after firing off the event. First thing we do, we decompose destructure the object, grab the kind of 4 things that we care about. Next thing we do, we grab the current slot based off of the slot index and the slot context. Then we grab the landing slot, likewise with the slot index of the target and the slot context of the target. Then we call remove item on the current slot. What does that do? Let's take a look. So first, it's going to check that you've actually initialized this functionality. If not, it's going to throw an error. So hopefully you catch this, develop time versus, runtime, or develop time versus finding it in, production. Then it's going to call remove item. Remove item is going to first check that it has an item, of course. If it does have an item, it's going to grab the item ID, remove the item from the slot sprite. So the slot sprite, again, is the rectangular slot that is like the container for the item to sit in. So it's going to remove, because the item sprite is a child of the slot sprite, it's going to remove the item sprite. Then it's going to destroy it. And then again, this is a phaser game object. So these are methods that exist on the kind of base game object in phaser. It checks to see if it has a quantity. So if you were to remove gold from a slot or any other item that can be stacked, it's going to go and destroy then the quantity. It's going to set item to null, and then it's going to return item ID. I think in some cases I actually use this item ID for something. So I needed to return it. Let's go back to where we called from. So we called remove item here, which came from the shop window manager. Oop, I cannot type. So removes the item. Decompose item, what does that do? Well, it takes an item entity and decomposes it into basically just the things that's needed in order for the inventory grid slot to render the item into an item slot. So we call this guy from, let's go back here, call it from this event handler. Then we say, okay, move it to the landing slot. So this functionality very closely resembles the internal state update function, which again, removes the item from the item slot and then moves it to the new item slot. After everything's been added, I guess we could take a quick look at what add item does. Again, checks that it's initialized. Add item will build the slot or build the item sprite into the slot. It's going to just set a reference to the item. It's going to add it to the scene. It's going to add it to, I guess this is where it actually adds it to the slot sprite itself. And then if it has a quantity, it's going to build the quantity game object. It's going to add the quantity game object to the slot sprite as well. And then it's going to subscribe to a quantity changed event. So let's go back. Its next step would be to call layout on the slot sprite. I'm not going to go into too much depth on what that means. So within Phaser, I use a UI plugin that automatically handles scaling and padding and just defining layout so that I don't have to do it by hand. So anytime you modify the UI, you call layout and things will move and adjust accordingly. So it's a really nice plugin. I'm happy to talk more about that, but I use it very heavily for my game. In this case, I emit an item added event. There are some things that use this behind the scenes, so I'm not going to go into that detail yet. We can go back up the call stack to kind of one final thing, which is update shop window. Update shop window. So what this does is it actually renders the updated value for the shop coins, the player coins, the in-play value, and the shop and play value. And those are the four things that are shown at the top of the shop window. And again, the shop window, as you see here, you've got the player gold, you've got the in-play gold, you've got the shop in-play gold, and you have the NPC gold. So that is pretty much it for the trading system, at least as far as examples go. Like I said, I did release the code for the trading system onto GitHub, so I will share that in the description of this video. If you enjoyed this content and enjoyed the walkthrough, would like to see more, feel free to subscribe or throw some comments down in the description of the video or in the comments of the video. If you like the way the trading system is set up or you want to use it, throwing me a star on GitHub would also be awesome. Would really appreciate it. But yeah, hoping to do more of these videos and break down some of the other systems that I've built. Just maybe as a precursor, got kind of a fully functioning action bar system down here. some different skills with skill timeouts, and can walk through how that was built as well if you guys are interested. But yeah, hopefully we'll be back on some sort of upload schedule. That's all I got for today. So we'll see you guys next time.